Okay, let's start topic one of statistical analysis for economics. So what we are gonna do today is basically we are gonna, talk about the introductory section of this course. So what is statistics? Okay, so this is Keller's textbook chapter 1 and Duan and Seward also chapter 1. Okay, so in this topic or in this chapter, we will talk about these 4 or 5 things. First one is what is statistics, because I assume you guys are learning statistics for the first time. So I will talk about what statistics is, and then as a discipline, as an academic discipline, and we will talk about descriptive statistics, what the definition of descriptive statistics, and the definition of inferential statistics, and the definition of statistical inference. And then we will talk about some important statistical concepts today. Okay. So first thing, what is statistics? Statistics is a way to get information from data. Okay. So data nowadays, data is very common word. So everybody talks about data, right? But in 10 years ago or 20 years ago, when I talked to my friend about the data, then actually one of my friend actually doesn't know what data is, what data are or what data is. Some people use data as a plural noun. Some people use data as a singular noun. So I will sometimes use data as a singular noun or also sometimes plural noun. Okay. So data is many things. Data could be numbers. Data could be text. Data could be image or recordings, shorts or clips, a lot of different things. But basically what statistics is doing is to get some information from data. Okay, we need the information from the data. So there is a data in the world. There are a lot of data, right? So many things are we can think about everything basically as a data these days, because we can even get some information from text, get some information from images or movies, clips, a lot of things, right? So from this data we want to get information. The most common thing that we are using from as a statistics is a mean, right? Mean is what 평균 in Korean, right? 평균, mean. So we try to use the mean to get an information about the data, how the data is, how the average number is in this data, right? So those kind of mean or average is a typical thing about statistics. So we use basically statistics as a discipline or method to get information from data. So statistics is a tool for creating new understanding from a set of numbers. Why here it is a set of numbers? In textbook setting, usually the data is the numbers. So for example, if you have a data about people's height, okay, height, right? These heights are numbers, like for example, some people has heights 190, 187, and so on until maybe 150, something like this, right? From these numbers, we try to get some information. One information that we want to know is the average of these numbers. So that is basically the mean, or later we will call it sample mean or sample average or something. Those things are basically the information. And why we use this statistics, right? Why we use this statistics? Because we want to know information about this data, right? So statistics is a tool, and a statistic as a noun, as a singular noun, is a single measure reported as a number which summarizes a sample data set. Here we have another interesting term, sample. Sample in Korean is a 표본. Sample is basically there are a lot of if you want to, for example, let me put it this way. If you want to know the average height of the Korean population, then you cannot survey all the Korean people's population. with for many different reasons. You may not have enough money, enough time to survey those people. Also, if you survey one person here, and then the other person may live like totally like different places. You cannot do it at the same time. And some people's height basically change over time. Like old people's height become shorter and shorter, and young people, like very young people, height grows every day, for example. So that's why you cannot get the sample in one day or in a short amount of time. So we need to have a sample, small sample, right? We cannot get the data for every people in Korean population. So we need to have a sample. Sample is a small number of set or groups or people that we want to get the information. We want to get the statistic, basically the data, right? So we have a sample data set and we want to have numbers. Then we use the statistics as a tool to get the information. And then a single measure that we summarize this sample is a statistic. Okay, so in Korean this is a maybe 통계학 or 통계량. This statistic is a 통계. Maybe let me my Korean translation may not be good. This is a 통계. This is 통계학 or what, I don't know. I'm not sure about this. This may be 통계 and this is 통계량. But statistics is a tool. Okay, tool. An important thing that we have to distinguish is statistics is a tool and statistic is a single measure. Okay, that's what I want to emphasize. Let's move on. We want to get some example. A student enrolled in an economics program is attending the first class of their required statistics course, ECO2011, statistical analysis for economics, and the student is somewhat apprehensive because she or he believes the myth that the course is difficult. Some people think statistics course or math course in the economics department is relatively more difficult than other economics courses. So they believe statistics course, this ECO 2011 is difficult. So to alleviate anxiety of this student asks the professor about last year's marks, last year's scores, right, for exam scores. Marks is basically the Australian English or British English about the scores. Okay, and professor, for example, myself, basically try to provide a list of final grade or final scores, which is composed of term work plus the final exam or midterm exam, and then that will have a lot of numbers. For example, like some people have like 95, 92, 65, 75, 61, These are the numbers, scores, right? Some people got 95, some people got 92, some people got 61. I hope you guys don't get the 61, by the way. But these numbers, there are a bunch of numbers. If there are 70 students took the exam, took this course, then sorry, then there could be 70 numbers, right? And these 70 numbers, these are basically the data, right? From this data, what information this person can get, okay? That information, in order to get that information, this person has to use statistics, right? And one possible statistic is the mean, right? Mean is a statistic, right? And the tool to get this mean, okay, how to calculate this mean, if you will add these numbers, 95, 92, 65 plus and then divide by the number of students, right? This is number of students, then you will get this mean, right? And this, how to do this is basically the statistics, right? Statistics, and this mean itself is the statistic, okay? That is basically the example of statistic, what statistics is, and the single statistic. Okay, if you guys are following this first topic, the introductory topic. So these are the numbers. Okay, the numbers are given here. These are basically the data, right? Data, and you can get the statistic from this data. Okay, these are the data. Okay, how do we know a typical mark? What's gonna be the typical mark? So one thing that you can think about is the mean. Mean is the average. If you take a average of these numbers, for example, we got 72.67, 72.67, and this could be a typical mark. Or you can think about the median. Okay, this mean is 평균, median is what 중위값 in Korean, or 중앙값 in Korean, or 중위수. Sometimes people use 중위수. There are many different translations. So that means there are 50% of these numbers are below this median, and 50%, another 50% is above median, right? So in the middle, the number, if you order these numbers from the highest to the lowest, and then exactly the middle one is the median, right? So median is, for example, like 72. Then 72.67 and 72 could be two possible candidates of the typical marks, right? Typical mark. And they are basically statistic. These guys are statistic. Okay, one statistic, the other statistic, right? And calculating these numbers are basically the statistics, right? So is this enough information? Then maybe the another question. Then you can think about how many marks are below 60 and how many marks are above 80. You are as a student who want to take this ECO 2011. You want to know what's the chance of you getting above 80% based on the previous year's course marks, right? So then maybe something that you want to know, that could be another statistic that you want to know. For example, like above 80 was like 20% of students get above 80. Then this 20% or 0.2 is the statistic that you may want to know, right? And that is the information that you want to know. And what is the proportion of A grade, and what are the proportion of B grade, and so on, right? What proportion are A, B, C, D grades are also the information that you want to know. I think a lot of students want to know what are what is the proportion of A plus grade for this class, right? A plus grade. Right? Those informations are something that you want to know, right? It could be different from year by year, so we cannot say a typical number. But if you have this kind of information data, then you can maybe calculate what's gonna be the proportion of A plus based on the absolute grading. If some people who get 95 or above is A plus, then you can count how many people get A plus, how many people got more than A plus, and how many people are in this course, right? From those two numbers you can calculate this, like A or A plus or B, C, D grade. I'm not talking about our rule of giving you A plus. Okay, I'm just giving you an example, saying that 95 above is A plus. It's just an example. Don't take this as a rule for this class. Okay. Second thing that you can think about is not just a number or not just a number measure as a statistic. There could be a graphical techniques. These days, graphical technique is very, very important. Right? There are a lot of different programs. Computer programs are good at drawing graphs. Okay, previously only not only, but some people usually often use Excel, Microsoft Excel to clean the data, not manipulate, right? Reframing the data, and then making graphs. These days Python are very good at drawing graphs. So there are Matplotlib, right? Matplotlib. You can use this package to draw some graphs. So not just the histogram, but there are a lot of different graphs. Also there are different types of graphs. Also, many other programs also can draw the graphs. So graphs are very, very important. If you are interested in drawing the graph, maybe you can use some YouTube lectures about the graphical techniques in Python, or SKKU may have some course about this data cleaning or data visualization. So data visualization is very important thing that you may want to study if you want to get a job in industry. But this is not our emphasize in this course, right? So I will very briefly only mention graphical techniques in topic 2, and we are not gonna cover many graphical techniques in this topic. Okay, so these are example of the histogram from the data here, right? We have this data, and if you could draw the histogram, then there is in the y-axis, the vertical axis, there is a frequency, how many observations, how many marks are in this 60, for example, this 60 to 69, how many marks are there? For example, like there are maybe 3 marks here, and 71 to 79 there are about 20 marks here, right? 20 marks here, and so on, right? So you can draw this histogram. You can sometimes use the frequency, or sometimes you can use the relative frequency, right? Relative frequency or proportion in the on the left vertical axis, and the horizontal axis there is a mark, and this is the typical example of a histogram. Okay. Now, next thing we want to talk about is the definition or term that is called descriptive statistics. Descriptive statistics deals with method of organizing, summarizing, and presenting data in a convenient and informative way. And one form of descriptive statistics is graphical techniques, like such as this histogram, right? And another way is the numbers using like a mean, variance, median, those kind of thing is also the descriptive statistics. In topic 2, we will talk about the graphical method, but very briefly. So I will not spend a lot of time on the graphical method. Okay, as I mentioned earlier, graphical method is not the key thing about or main thing in this course. Okay, so why we use this technique? Because these techniques will give a way to present data in a way that is easily understandable by the data users. Okay, so that's why we use graphical techniques or some other techniques. There is also numerical techniques as we have seen in the previous slide. Mean and median, range is the in the data, the largest number minus the lowest number is basically the range. If you have your data with this course scores, then the top score minus the bottom score is basically the range. We will talk about this in topic 3. In topic 3, we will talk about these things: variance, standard deviation, and the variability of the data. But there are many different descriptive statistics: maximum, minimum, first quartile, second quartile, percentile, and so on. There are many different things. Okay, in chapter 4 in the textbooks, and topic 3 in our lecture note, we will cover these different numerical techniques. Okay. So far we talk about the descriptive statistics, numerical techniques of the descriptive statistics, graphical techniques of the descriptive statistics. And another important statistics is inferential statistics. What inferential statistics is, we talk about before we talk about this inferential statistics, let's look at this example about Pepsi's exclusive agreement. Okay, exclusive agreement. A large university like SKKU, with a total enrollment about 50,000 students. There are a lot of students, right? 50,000 students. In this university has been offered by Pepsi Cola about an exclusive agreement that would give Pepsi an exclusive right to sell their product at all university facilities. Okay, for the next year with an option for future years. In return, the university would receive 35% of the on-campus revenues and additional lump sum of $200,000 per year. And Pepsi has been given 2 weeks to respond. So university basically offer Pepsi instead of Coca-Cola. Pepsi was offered. University basically actually, I put Pepsi offered, but the university actually offered. Okay, university offered Pepsi. That Pepsi can sell their product exclusively in university, in this university as KKU, and then Pepsi has to give the 35% of the revenue to the university, and also $200,000 per year to the university. And Pepsi has to respond in 2 weeks. So if Pepsi agrees, then all these other products like Coca-Cola or Donga Otsuka or all those like other product beverage product will be disappeared in the university facilities. Only Pepsi will leave in this university, right? Then what Pepsi has to do is Pepsi has to estimate. Pepsi has to guess what's gonna be the sales amount, right? Sales amount. How many cans or how many beverages they can sell, right? And they have to estimate or guess their profits. Okay, so this market for the soft drink, like Pepsi soft drink, is measured in terms of 355 milliliter cans, right? And Pepsi currently sells an average of 22,000 cans per week over the 40 weeks of the year that the university operates. And the cans sell for an average of 75 cents. It's a very old example. Okay, these days I think 355 milliliter can is like maybe $2 or something, or $1.5. Okay, 75 cents each, and the cost of including labor amount is 20 cents. So each can, if they sell 75 cents, then 20 cents is the cost. Okay, then 55 cents will be the margin, right? Margin that they get, and they sell 22,000 cans per week without exclusive agreement. Without the exclusive agreement, Pepsi is selling 22,000 cans per week. So 22,000 times 40 times 0.75 is the sales, and then the cost is a 20 cent per can, right? And Pepsi is unsure about their market share in this university market, but they think they are quite low. Relatively, considerably lower than 50%, so maybe 30% or something. Okay. And the quick analysis that Pepsi does, this analysis reveals that their current market share is about 25%. If this is true, then Pepsi will sell 88,000 with the exclusive agreement, right? With the exclusive agreement, 88,000 cans per week, and 3,520,000 cans per year can be sold with this exclusive agreement, and then profit can be calculated. You can calculate 3,520,000 times 0.55, right? Then this is gonna be their profit, right? And then they have to give 35% of this to the university, and then what? This $200,000, dollars as an exclusive agreement, as a lump sum. So then their profit will be this number, the sales times 0.65, because 35% they have to give to the university. 65 minus 200,000 will be the profit, right? Their profit. I will use this pi. Profit is this, right? This much. We don't have to calculate this. The calculating this is not the point of this example. The point of this example is what the inferential statistics is from this kind of example, right? Okay. The only problem is that they do not know how many soft drinks are sold weekly at the university, right? So from this example, they say they would sell 88,000, okay, and their current market share is 25%. This is basically what they wanted to know, right? How many soft drinks are sold weekly at the university? So they have to basically guess, and they this kind of guess process that they have to do, right? They have to do. So this kind of thing is what they have to do. So Pepsi assigned a recent university graduate to survey the university student to supply the missing information. So these recent graduate, for example, like statistics graduate or economics graduate, organize a survey that asks 500 students to keep track of the number of soft drink they purchase in the next 7 days, in order to get the idea about how many soft drinks are sold weekly. So they basically survey 500 students for next 7 days how many soft drinks they will consume, right? That's what they wanted to do. So and then basically they want to estimate, they want to get the information that they want to acquire. In this Pepsi example is an estimate of annual profits from the exclusivity agreement. Why Pepsi want to do this? Because whether they will get more money with exclusive agreement or without exclusive agreement. In order to do that, they have to know how many soft drinks are consumed in this university, right? To do this, we need to have another branch of statistics, that is inferential statistics. To having getting some estimate from the sample, okay, that is basically inferential statistics. So we will learn this inferential statistics in the later chapters, probably after the midterm. Okay. So go to the formal definition. Inferential statistics is a body of method used to draw conclusions or inference about characteristics of population based on the sample data. From the sample data, okay, this sample is from a population. You can think about the Korean population, right? Population is we want to know some property about the population, but population is hard to, survey. So we want to survey only the sample, okay? And sample is based on this population, right? From this population, we basically get the sample and sample data. And from this sample data, we want to draw a conclusion or inference about this characteristic of population. That's what we do in this inferential statistics. So inferential statistics is a method. Okay, method used to draw conclusions or inferences about the characteristics of population. And here the population in the previous example is the 50,000 students in the university. So population could be different. If you want to know Korean people's average wage, right? Then Korean people is basically population. If you want to know, the average age of SKKU student, then SKKU student is the population, right? Okay, so population could be different, right? And the cost of interviewing each student would be, could be large if you do survey for a lot of students, more than maybe 10,000 students. Then the survey costs are quite, big. So that's why you cannot survey all the population instead of you have a small number of sample and do the survey, right? Check their data from this sample. So we have a sample. We have a sample which is much smaller number of students. Here is 500 students, and from this sample, okay, we get the data, which is the number of soft drink consumed by the number of soft drink consumed by these 500 people. From this data, we infer the number of soft drink. We infer the number of soft drink consumed by all 50,000 students. It's very intuitive, right? You have 500 students, and their amount of soft drink consumed in a week. With these numbers, 500 numbers, we infer how many soft drinks will be consumed by this population of 50,000 students, right? That's what we do in this inferential statistics. Then we can estimate the annual profit for Pepsi with the exclusive agreement. Okay. Next thing is a statistical inference. Actually, I don't want to distinguish these two terms, inferential statistics and statistical inference. Inferential statistics is a method, right? Method to draw conclusions. Okay. Then statistical inference is what? Statistical inference is just doing this, using this inferential statistics. So this process of using the inferential statistics is a statistical inference. So you don't have to, distinguish too much about these terms, inferential statistics and statistical inference. Statistical inference, just looking at this example, and we will move on. When an election for political office takes place, the television networks, like TV news, like KBS, NBC, and SBS, JTBC, those kind of television networks try to, guess who's gonna win the election, right? In the previous election, presidential election, you may have seen those kind of exit polls, like 사전, not the 사전 투표. Exit poll is what? 출구조사, right? Exit poll, and after the exit poll, they basically, guess or estimate who's gonna win the election. They predict, right? They basically predict who's gonna win the election, right? And after the ballots, right, 투표용지, right, ballots are counted, the result is gonna be, reported. But for important like officers such as president or congressmen in the large state, large places like 도지사, 국회의원, right, and governor, mayor, those kind of important things, the networks try to try to predict who's gonna win these elections, right? And those kind of things is done by exit polls, through exit polls. Right? Exit poll is a 출구조사, right? And a random sample of voters who exit the polling booth is asked for whom they voted. Like for example, every 10th voter is surveyed, and then ask them who did you vote for, right? And then they use this data to estimate or to predict who's gonna win the election, right? Okay, so from the data you can calculate the sample proportion of voters. Like if there are 100,000 voters who voted, but you only maybe use the sample of 1,000 voters, and what's the proportion of voters voted for candidate A and candidate B and so on, and then you can basically predict who's gonna win the election, right? So that's basically the inferential statistical inference, right? That's the process of statistical inference, and using the inferential statistics. Okay, that's the process of using inferential statistics, and that is statistical inference. Okay, and they try to infer the leading candidate will get enough votes to win the election. Okay, that is the statistical inference. For example, in 2000, I think before most of you guys were born. Sorry. In 2000 election of United U.S. president, U.S. presidential election in 2000, there was George W. Bush and Albert Gore in Democrat, George W. Bush in Republican. Their election in Florida was very, very close. Okay, and for example, some TV network basically surveyed 765 voters whether they voted either for Bush or Gore. One is Gore and two is Bush, and they ask whether you voted for one or two. Okay, one is Bush, one is Gore, and two is Bush. And from these, numbers, how many ones they have, how many twos they have from these 765 people, and then from this they can guess. Okay, they can predict who's gonna win this election in the state of Florida. Okay. And then this is basically common application of statistical inference. There are 5 million Floridans voted for either Bush or Gore, and only maybe 765 people. If more, then it's better, but it will cost more money. So only the 765 people's vote, whether they voted for Gore or Bush, they can still infer who's going to win the election in the state of Florida, right? Okay. That is basically the statistical inference. Okay. And when you get these 765 people, those 765 people must be randomly selected from all over the Florida, and they have to have the similar characteristic as the population. Otherwise, you cannot accurately predict who's gonna win the election, right? If those among those 765, if more than 50% of the people voted for Bush, right? Sample voted for Bush, then we can predict. They can predict, the network, TV network can predict Bush will win the state of Florida. Okay, but still there are 5 million people in Florida, and we only use 765 sample size of sample. So our guess is not gonna be, our prediction is not gonna be 100% sure. So you may give those kind of numbers. Okay, 95% chance, 95% probability that Bush will win the state of Florida. Those kind of giving some room that you can make some mistake with this small amount of sample is basically the statistical inference. And what exactly the probability that your prediction is correct, those probability, giving those probability, for example, like between 90% to 95% probabilities Bush will win the state, those kind of numbers, giving those kind of numbers is basically the statistical inference process, okay, which we will go over in the later chapters. I'm just giving you an introductory background, introductory understandings. We will try to get this introductory understandings in this part. Okay, there are key statistical concepts that I want to mention. Population, we already mentioned population. Population is what? The formal definition of population here is the group of all items of interest to statistics practitioners. So it doesn't have to be a number. It doesn't have to be a people. It could be some product, or it could be something, right? It could be animals, it could be people, it could be houses, it could be countries, it could be farms, many things, right? So the group of all items of interest to statistics practitioner. So here important thing that I want to emphasize, all, right? Population is all things. As a practitioner, you want to know the feature of this group and all the things that, all the items that you are interested in, right? Okay, it could be very large. 5 million Florida voters are the example of the population. And the next one is a sample. A sample is a set of data drawn from a population. Set of data drawn from the population. From population, we draw several people from this population. So 765 voters who did exit poll on the election day is an example of the sample. Sample can be also very large. 765 is actually large numbers. These days, people often talk about 1 million, 1 billion, like those big numbers. But 765, like 100 years ago, if you are surveying 765 people, it's difficult. Actually, it's quite large numbers. But these days, 765 looks like very small. There is a sample size inflation. But, 765 these days actually is not large in terms of the data size, but sample could be very large. Sometimes some sample is 1 billion observations and so on. Okay, and two important things that actually one important thing we haven't mentioned so far is a parameter. Parameter is a 모수. 모수 is a population number. Mo is actually mother, but mo is a population. Parameter is actually descriptive measure of population. Okay, there is some feature of population that we want to know is a parameter. Statistic is a measure of a sample. Okay, so parameter and statistics is a counterpart. They are counterpart with each other. Okay, so in the population there is parameter. In the sample, you have statistic, and with this statistics, you have to infer about this parameter in the population. Parameter in the population. Okay, so population is here, and there are many items here, right? And from these items in this population, we draw a sample, right? Sample is smaller than population, but here are also items. So, for example, this item is this guy. And 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 so on. It's a sample you draw. Okay? You draw. There are 100 people in a class. And I can draw 5 people from this class, right? Okay? There are drawn sample. Sample is drawn from population. And population have parameters. And sample have statistics. Okay, population have parameters, and sample have statistics. Okay. So what we want to know is a parameter in the sample. Parameter in the population, and using the sample we calculate the statistics and to infer these parameters using these statistics. Okay. Descriptive statistics, again, a method of organizing, summarizing, and presenting data in a convenient and informative way. Graphical techniques and numerical techniques will be, discussed in the later chapters, topic 2 and topic 3. And descriptive statistics is basically naturally, as the name suggests, it describes the data set that's being analyzed. Okay, that's being analyzed, but that doesn't allow us to make any conclusions or make any inferences based on this descriptive statistics. We want to draw some conclusions or make some inferences. We have to use another branch of statistics, that is inferential statistics. Inferential statistics is a method. And it is used to draw conclusions or inference about characteristics of population based on the data from the sample. Okay. And statistical inference is basically the process of making an estimate. Okay, estimate like a Pepsi's profit, estimated profit predictions, like whether Bush or Gore win the election, or Trump. I think for you guys, Trump or Biden. It's not Biden. Who was I forgot the name of the other candidate. Okay, Trump and the Democrats candidate. Who was the Democrats candidate? Trump and Democrat candidate. I forgot. Let me try to. Harris, right? Harris and Trump, right? Who's gonna win the election? Whether it's Trump, whether it's Kamala Harris. Okay. those kind of thing. Making a conclusion is basically the statistical inference. Okay, we try to infer population's parameter. For example, like population average, we want to infer this population average based on the sample average, and sample average is a statistic. Okay, sample statistic. We use sample statistic to infer population parameters. Okay, we try to get an estimate, prediction, or decision based on the sample data and about the population. We make an estimate about population, prediction about population, decision about population based on the sample data or sample statistics. Okay, that is what we are gonna do in this course. So what we are gonna do is we will learn descriptive statistics, graphical descriptive statistics, numerical descriptive statistics, and then we will talk about inferential statistics. We will do test we will get the estimator first, and then we will do predict. We will test whether some hypothesis is correct or not. We will make a interval estimate, and so on. We will do those kind of things in this course. Okay, and that's pretty much what I want to mention in topic 1. So if you have any questions, please feel free to ask me questions. You can use my email. You can also use send iCampus message to send me an email. Okay, so please don't hesitate. Send me an email or ask me questions using any kind of method. Okay, that's it for topic 1.